So in the last video we did a problem where we were finding the equation of the tangents to the parabola. So hopefully you've already watched that video. Alright, and that well, that was more in section 11.2. Like, there's a weird little section between 11.2 and 11.3 in the textbook. Alright, this is the proper 11.3 for this example that we're going to do now. Alright, in 11.3 there's just a lot of applications of what we do. There's going to be some other equations where they find tangents to the curve and use some of the similar techniques. But here's another question that's going to be asked, and it's going to be a little bit more in the worksheet rather than in the book problems. So for this one, we're going to look at finding the equation for the parabola. Okay, and in this case, with an oblique directrix. Okay, and oblique means that it's neither horizontal nor vertical, right? That's slanted in some way, shape, or form. So let's say that our directrix is going to be y equals 3x minus 1, and our focus, we'll say our focus is going to be 3, 2. Okay, and if we think back to the definition of a parabola, it's the set of all points that are equidistant from a line, the directrix, and a point. So we need to make sure that any point on this parabola, right, is equidistant from these two objects. So let's call the point on the, we'll do this in pencils so it can erase in case it makes a mistake. Okay. So, right, so we have a point on the parabola, and we'll just call that x comma y. Right, and that's great because that's any point that we could possibly have. Okay, so let's see. The distance from that point to the focus, right, would be the distance formula. So x minus 3 squared plus y minus 2 squared, and that distance needs to equal the distance from this point to that line. So, well, we'll change that line to general form. Right, so 3x minus y minus 1 over the square root of 10, 3 squared plus 1 squared. So this is our distance from a point to a line equation. That's our distance formula between 2 points. Okay. So at this point, we really just need to go ahead and solve this one out. We have to, kind of do a little bit of math here. So let's square both sides, and we'll get the x minus 3 squared plus the y minus 2 squared. The bottom is going to be 10. The numerator is going to distribute out because we're basically going to be taking 3x minus y minus 1 and squaring it. Okay. All right. It's not okay to leave our answer this way. We have to combine as many like terms, so we have to do a whole bunch of algebra here and distribution. So, all right, it'd be nice if we could just leave it that way, but we cannot. So, and you'll see why as we do this problem. Oh, you know what? Let me also scale by 10. Right, bring that to the other side there. I don't want a fraction there. So 9x squared minus 3xy minus 3x minus another 3xy, so that becomes a 6 plus y squared plus y minus another 3x, so we get minus 6, right, plus another y, and then plus 1. So let me just double check my terms and make sure everything looks good for signs. Okay, we're good. Okay. If we distribute out the 10, okay, that's our next term there. Okay. And now I'm going to move everything over to this side, so I'll subtract. Right. I'll move the y squared term over, so that will come over that. Okay. Put the xy term next. That's the next one we usually write, so we'll move that over. So we have a plus 6xy. There's no terms to combine it with for ourselves. Oh, I forgot to distribute the 10 there and there. So we have those. Did it distribute? It distributed there and there, but not here. That was interesting. All right, randomly picking and choosing which terms to have. Okay. Let's see, minus, let's see, this is going to be moved over to this side. We're going to add 6x to both sides, so that's going to become a minus 54x. Okay, for the y terms, we're going to subtract 2y from both sides, and so we're going to get minus 42y. And then if we look at the constant terms, we have 130 here. We're going to subtract 1, so we'll have 129. Okay, and that's our equation. If we take a look at it, we can see that it in no way, shape, or form looks like the parabola equation we had before, and that makes sense when we start to think about the fact that this is not a normal parabola, right? If we think about our graph here for it, right, this is what our graph would look like. Okay, and our directrix is okay, so right there's our directrix. Okay, and our focus is 3, 2, right here. Okay, so if we're thinking about a rough estimate of what this graph looks like, well, let's see, here's the axis of symmetry, right? And the vertex would be about halfway, and we can figure out where that is, and we will in a second here. So our graph's going to look something like this. So we see that we have a conic that's rotated, right? So the big takeaway from this is that we have a rotated conic because we have an oblique directrix. Okay, so anytime you have an oblique directrix here, right, you are going to have a little different equation here. Yes, it has x squareds and y squareds in it. That's kind of different, right? But that's just because of that rotated conic. Anytime you're trying to write an equation and you're given the directrix and the point, right, you can always do this derivation, right? If it's slanted like this, you have to do derivation. If it's horizontal and vertical directrix, right, then I don't expect you to do this derivation. I expect you to use that shortcut. So other things that you might be asked to do for this one, you might be asked to say, okay, where's the vertex? And if we want to try to find that vertex here, right, it looks, if we're graphing it, it looks like we can find it pretty easily, but what we really need is we need to know this intersection point right here. So we could find the distance here, right, just by using our distance from a point to a line, but the problem is that's just going to tell us like how far these are. That's going to tell us our p-value. It's not going to necessarily tell us the coordinates of this, okay? So we could use the distance from point to line to tell us what, how many units that is, but since it's slanted, that won't necessarily tell us our coordinates. So here's what we're going to do instead. We know that the equation of this line right here is 3x minus 1. We can find the equation of this line. We know that it's going to have a slope of its slope is perpendicular to that slope, so it's going to be negative 1/3. So if we know that that's a point on it, right? 3, 2. So we have that equation for ourselves. Okay, and if we can then find the intersection of these two lines, right? And to find that intersection, we're going kicking the algebra 2 style here, right? We have these two, and I'm just going to use substitution and plug it in, right? So I'll plug that in with a 3x minus 1. Okay, we're going to scale everything. I'm going to scale. Actually, let me combine. I'll just distribute because that's actually not going to be too bad there for myself. If I scale everything by 3 now, just so I don't have to deal with fractions, move that over, I get 8x equals 12. So x equals, let me make sure, 10, because I'm adding, and I'm going to get 6/5 there as my x value. So that's the x value of the intersection. So I can plug that in and get the y value of the intersection. I'm plugging into the slope-intercept form because that's going to just seems like the easier one to use. 18/5 minus 5/5, so it's got 13/5. Okay, so I figured out that this intersection point right here is going to be 6/5, 13/5 for me. Okay. And to find the vertex, well, it's on a line here. We know it's the midpoint, so we could just say, hey, let's find the average of those two. So it's the midpoint on the axis of symmetry, between the vertex and that new point. We'll just call it that new point. P. Okay. And so let's go and do that average there. Right. Not let's see. So 6/5 averaging with 3 over 2 for the x values, and for the y values 13/5 averaging with 2. Right, cut in half. And we do a little bit of math there, and it comes out to a vertex of 21/10 and 23/10. Okay. So since it was asking for the vertex, right, I did the intersection of the points and then did the average. If it was asking for the value of p, right, then I've probably done this differently. I probably would have done distance between point and line, right, this point and this line, and that would have told me how far this is. Cut it in half, and it tells me my p value. So there's just some different questions you might see as you go through the worksheet that you can answer from there.